Welcome back to another AP Physics 1 math review. This video is going to be based on the algebra review portion of the summer assignment. Algebra is a very important skill in AP Physics 1, but don't worry if you don't know it. At this point, you're a little bit rusty with your skills. We have the entire year to get to that point to get you better. It's really important first that you understand the physics, and the algebra will just help you be able to make predictions based on that. And the algebra is not really that bad. You're not doing anything crazy with it. It's just isolating variables like in these examples on the summer assignment and in the video. So if you don't get it right now, don't be too worried. This is really new to most of you, especially the way these equations look. So just get the practice in with this and with the summer assignment, and we're going to get you there through the school year. So that being said, let's get into our first example. So this example, this equation is not actually in the summer assignment, but it's just a good introduction into being able to solve for variables or isolate variables algebraically. So what we have here is an equation we'll use later on in the year. Not worried about what it means at this point. We're just trying to get used to solving for variables. So here we have solved the equation for v. That is the variable on the very top of the equation, or you could call it the numerator. So whenever we do algebra and we're trying to solve for a certain variable, you want to quote-unquote isolate it. So what that means is you're going to do math operations to get this variable on one side of the equation by itself set equal to everything else on the other side. Here we are trying to isolate this v on one side of the equation and have it set equal to everything on the other side. So with this, we're going to do math operations. So we have to see what is attached to it and then do the opposite operation of that to then cancel out whatever is attached to it. Then that will then move to the other side of the equation. So this situation we have here AC. The C here is just a subscript. It is not a variable. So you don't have to worry about like manipulating that or getting it away from A if you ever have to deal with stuff like that. You're just dealing with, it's just telling you what this means. When we get to it later on in the year, it's just the acceleration or centripetal acceleration. So for this, I want to get V by itself. What I see attached to it, first, it is being squared. We're not going to deal with that right at the moment. But also attached to it being divided by v squared is going to be r. So when we do all this again, we're going to do the opposite math operation. So since we are dividing r out, what I'm going to do is multiply by r on both sides of the equation. So if I multiply by r over here, it will cancel it on the right side. Then on the left side, I'm going to have r times a subscript c. So just writing this out a little bit nicer. A subscript c multiplied by r is going to be equal to v squared. So then what I want to do with this, again, I'm trying to get v by itself on one side of the equation. What I have here is that v is being squared. So again, we're going to do the opposite math operation. So the opposite of squaring a number is taking, or a variable is taking the square root of the variable. So for this, I want to take the square root of both sides. Again, whatever I do on one side of the equation, I have to also do to the other side of the equation. So to get v by itself, I must take its square root. And then I will do the square root on the other side of the equation as well. So I'm going to end up with the square root of a subscript c multiplied by r is going to be equal to v, and that's going to be my answer for number 1. So that's how you're going to deal with different operations for this. Next few examples should be equations from the summer assignment, just with different variables that you are going to be solving for. So let's move into our next example. All right, so example number 2. We'll solve the equation for A. Again, we don't need to know what this equation means. At this point, we'll learn it within about the first week of school. What I have here is v equals v subscript 0 or v naught. again, this 0 looking thing here is just a subscript. That's telling me, that's denoting it from the original v that is equal to on the other side of the equation. Just kind of shows what this v means essentially. Then we are going to add a times t. So I'm going to try and solve for a here. So again, what I want to do here is isolate a on one side of the equation and make sure that that is then equal to everything on the other side. So the first thing I see here, before I get rid of what's attached directly to a, what is attached to a t on the right side of the equation. I see it's attached to v naught by this addition sign. So the opposite of addition is subtraction. So that's going to then get rid of my v naught on the right side of the equation. So subtract that from both sides. This will cancel out over here. I will then have on the left side of the equation v minus v naught. So I can write this out over here. V minus v naught is equal to a times t. So my last part here, I want to get a by itself. So now we want to see what a is attached to. Is attached to t by multiplication. So again, we want to do the opposite mathematical operation. So in order to detach my t from a, the opposite of multiplication is division. So I will do the opposite of my multiplication here and divide out t from both sides of the equation. So on the right side, I will cancel this out. On the left side, I should have this now, v minus v naught over t. So then my answer here, and I'll probably write it out a little bit nicer, so v minus v naught over t is going to be equal to a. If you want to write it out like this as well, as just a is equal to v minus v naught over t, that's obviously acceptable as well. It's just the like reverse of it. It's kind of the way like humans usually read things when you have it set equal to. So this is your answer here. A is going to be equal to v minus v naught over t. That's getting a isolated on one side of the equation. Everything else is going to be on the other side of the equation. So we have a equal to all the rest of my variables within the equation. So let's move into our next example. All right, so we have here another equation we will use later on in the year. Solve the equation for m. So we have here k is equal to 1/2 m times v squared. So again, we want to get m on one side of the equation all by itself equal to the rest of the variables within the equation. So I'm looking at this right now. What do I have attached to m? I have both 1/2 attached to m and I have v squared attached to m, both by multiplication. So we can actually divide these all out at once if we'd like to, or we could do them kind of like separately. Also, you could write this out as well like this. So k is equal to m v squared over 2. This can give us a different look for if you want to write it out like this. It's the same exact idea. So we'll start off with this. K equals m times v squared divided by 2. So what I'll do here first, I want to attach the 2 or detach the 2 from my m here. So in order to do that, since it's being divided, since m is being divided by 2, you're going to do the opposite of this and multiply 2 on both sides of the equation. Again, anything that you do, it's going to be the opposite mathematical operation to detach it from our variable we want to solve for, and then it has to be done on both sides of my equation. So since I'm m divided by 2, I'll do the opposite of this and multiply by 2 on both sides of the equation. So now on the right side, this will cancel, and I will have here k, or 2k. I'll have 2k is equal to mv squared. So now from here, we should only have one step left because we are solving for m. We're not solving for v, so we don't have to do the square root For this one, like we did earlier with the AC is equal to v squared over r. With this, I have 2k is equal to m times v raised to the second power. Again, my mass is attached to v squared by multiplication, so I'm going to do the opposite mathematical operation, which is going to be division. So I'll divide out v squared from both sides of the equation. So now I should end up being left with that my mass m, let's not say it's mass at this point, that's for later on here, my m is going to be equal to 2k over v squared. So this is going to be my answer again. We have the variable that I'm looking for. M is on one side of the equation. We have the rest of the variables on the other side of the equation. So our M is isolated, equal to everything else. So this is going to be my answer. M is equal to 2k over v squared. So let's move in to our next example. All right, so this example here, we want to solve the equation for v naught. So again, v naught is one variable. It's just telling me what type of v it is. We'll get into it. It's going to be velocity, what type of velocity it is when we put a subscript with it. What we have here now is delta x is equal to v naught times t plus 1/2 at squared. So this triangle here, that is what is called delta. It's just saying a change in x, essentially. You should probably have seen it in previous math classes. Again, this is attached to the x at all times. It's not something you have to divide out from it. So it goes with the x when you move it around, but you might not have to move it around for this situation anyways. So what we have here again, I want to solve for v naught. So I'm looking at this equation. I have v naught times t plus 1/2 times at squared. So the first thing I want to do with this, like one of the equations earlier, I just want to attach the thing that is being added to my v naught times t, then worry about getting rid of the t later. So what I have here is an addition sign. So I'm adding 1/2 at squared to the part of the equation that has v naught times t. So I want to attach this and get this to the other side of the equation, so because I want v naught on one side of the equation by itself. So the opposite of doing addition, the opposite mathematical operation, is going to be subtraction, and you can subtract this entire term out on both sides of the equation at once. So minus 1/2 at squared. This will then cancel it out on this side. Then on the left side, you're going to have the same exact thing, minus 1/2 at squared. Remember, you have to do the same thing on both sides of the equation. So I'm going to have here is delta x, or the change in x, minus 1/2 at squared is equal to v naught times t. So our last step here is going to end up being, I have v naught times t on the right side of the equation. I want to get this on one side. I want to get v naught by itself on the right side of the equation, or on one side of the equation. Right now is attached to t by multiplication. So then you must do the opposite mathematical operation, which is going to be dividing out t from both sides of my equation. So if I divide out from the right side, it will cancel out over here. And then if I divide out over here, I will have this. So I'm not going to cancel out the t on top. You don't want to go like too far with this. Whenever we do something like in the AP exam, you have an equation like this. You don't want to go too far and make a mistake mathematically or algebraically. So if you have something where it's going to end up being here, so I'll write it out the rest of the way. So the change in x minus 1/2 at squared all over my time. I don't want to cancel out like the t squared on top here and have to deal with that in any situation. So just leave it like it is right now. You don't want to make any silly mistake when you went through all the hard algebra here. at the very end. So I'm going to write it out again like this, where I have v naught is equal to the change in x minus 1/2 at squared all over my time, or all over t. So t is going to be time when we get to it, but don't worry about that at this point. Just worry about it as the variable being t. If I say what the variable means, it's just by force of habit. So let's move into our last example. All right, so our last example here, solve the equation for k. This is probably one of the tougher equations to work with. You can see on your summer assignment you have another version of this, which we'll use in AP Physics 1. For this one, you end up using it in Regents. It's a very similar equation to the one we use in AP Physics 1, so it's something that you kind of like review, but just with a different concept later on in the year in Regents. So for this, I want to solve for k. So again, we're using the rules of we have to isolate this variable on one side of the equation, and we have to detach the things that are attached to it by doing the opposite mathematical operation. So I have here f subscript e again. Again, that e is a subscript, so it's just telling me what the f means. And then the same exact things with the two q's there. It's just telling me that that is q number 1 and that is q number 2, essentially. So what I have here first, I have k, q1, q2 all over r squared. So what I have with this is my k is being divided by r squared. All of it is actually being divided by r squared. So what I can do with the r squared is multiply it on both sides of the equation, because again, that is doing the opposite mathematical operation. It will cancel it out on the right side and move it to the left side of the equation. So what I have here is multiply this by r squared. This will cancel out on the right side, and I will have on the left side r squared times fe, or I'll just write out as f subscript e times r raised to the second power is equal to k q1 q2. So now with this, I'm probably going to do this in 2 steps just for clarity reasons, but you can do it in 1 step from here. So I have k times q1 times q2. Both these being multiplied to k, so I could actually divide them both out at once, because that again is the opposite mathematical operation. But let's divide out by each of them in their own steps, just to make it more clear if you're kind of confused on where that's coming from. So again, I have here k times q1 and also multiplied by q2. So to do the opposite operation, that is going to be division. So I want to just divide out the q on both sides. So I'm going to start off with q1 here. Again, I could do this in 1 step if I wanted to, but I just wanted to show each step clearly. So I have here my q1 will cancel out on the right side. Then I will move it over to the left side. So I'm going to have here fe times r squared all over q1 is equal to k times q2. So in the last step here, I have k multiplied times q subscript 2. So we want to do the opposite mathematical operation once more. So the opposite of multiplication is going to be division. So we are going to divide out q2 from both sides of the equation as well. So then I'm going to end up with up here, k is going to be equal to f subscript e times r squared over q1 over q2, or times q2 at that point. So with this, once we get to this equation, we actually won't probably solve for k, but it's just a good way of getting used to isolating variables. You probably solve for q1 or q2, but same exact idea as we went through here. You get a very similar looking equation for it, just with the variables in different places. But again, we have here k, which is what we're trying to solve for. This is equal to all the other parts of my equation on the right side of the equation. I've used the opposite mathematical operations to detach what was originally attached to k, moving it to the other side of the equation. We did everything on both sides. We have an isolated variable. This looks good. So if you guys have any other questions, feel free to let me know in the comments or let me know by email. I hope this is helpful. I will also make the last video there for the geometry and trigonometry at some point before the summer assignment is due. So have a good day and good luck on the rest of the summer assignment.